All righty. So good morning, everyone. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. So today we're going to wrap up chapter 8. We're going to look at section 8.9. Your homework tonight is going to be section 8.9 as well as the chapter review. Tomorrow during class we will review, and then on Monday there will be no class meeting. You will just come in and take your test. Again, you can take the test anytime from now until Monday night at 11:59 p.m. In fact, that's true of any of the assignments or any of the tests. You can always take them early. It's just taking them late that's you can't do. Okay, so let's get started here. And so 8.9. Our topic is called variation. And there are three types of variation we're going to look at today. Each one of them has a specific formula that is used for that type of variation. So we'll look at a formula, an example, another formula, example, et cetera, et cetera. The first variation we're going to look at is called direct variation. Now, a general form of that formula is y equals kx. K is known as the variation constant. It's also referred to as the constant of variation or the constant of proportionality. I call it the variation constant because that's the shortest description. What's going to happen, K will be present in all of the formulas. Most of the time, it's not even mentioned though. And what'll happen is this. They'll give us a scenario and they'll tell us everything but K. We'll use that information to determine what K is for that scenario. Then we'll plug that value in for K, and then there'll be a follow-up scenario using that K value. All right, now, direct variation, the reason it's called that is because in this situation with this formula, if X goes up, Y goes up. That is, if X increases, Y increases. If X decreases, Y decreases. So they go up and down directly. Okay, so let's take a look at an example. A second here to find it in my book. Okay, this says free fall. An object in free fall travels a distance s that varies directly to the square of the time t. If an object falls 1,024 feet in 8 seconds, how far will it fall in 10 seconds? All right, so let's go back to the beginning. An object in free fall travels a distance s. So s equals distance, or distance traveled. Okay, let's see. An object in free fall travels a distance s that varies directly to the square of time t. So t is going to equal time. So s varies directly as the square of time. So s equals kt squared. Again, notice I inserted k there. Wasn't even mentioned, but it's in all the formulas, all the variation formulas. All right. So we've got s equals kt squared. Any questions so far? Okay. Now, let's go back and look at it again. An object in free fall travels a distance s that varies directly to the square of the time t. If an object falls 1,024 feet, so that's the distance traveled, in 8 seconds, so the time would be 8, we get the following: 1,024 equals k times 8 squared. I want to point out that the most common mistake that students make with this is if there's like a variable squared or cubed in the original formula and they plug in the numbers, oftentimes they'll forget to take the squared with them. So be careful of that. All right, so we've got 1024 equals 8 squared is 64. K times 64 is the same thing as 64 times K. So now I can divide both sides by 64 in order to solve for K. So I've got 1024 divided by 64, and I get 16. So the variation constant for this problem is 16. So now this is going to go up in here, and now our formula looks like this. Okay, so we had a description of the formula. We had some information that allowed us to determine what K is. Now there's a follow-up question. It says, how far will it fall? So that's S in 10 seconds. Okay, so the distance it falls is 16 times 10 squared, which is 16 times 100, or 1600, and that, let's see, the units are feet. Any questions about this example? All right, so again, direct variation in general, y equals kx or y equals kx squared, or, in other words, the variable on the right can be cubed or squared or whatever. As one goes up, the other goes up. As one goes down, the other goes down. Okay. Second variation formula is called inverse variation. In general, it looks like this: y equals k, k divided by x. So we have sort of an inverse or a reciprocal situation where the variable on the right side is on the bottom. K is still there, K is on top. What happens in this case, as X increases, Y decreases. As X decreases, Y increases. So they have this, it's not direct, it's inverse. Okay. Let's take a look at an example. Okay. The frequency of vibration of air in an organ pipe varies inversely to the length of the pipe. All right, so we've got, let's see, F is going to equal frequency of vibration. Okay, and L is going to equal the length of the organ pipe. All right. The frequency of vibration of air in an organ pipe, so that's F, varies inversely to the length of the pipe. So that's where we get our formula. Good with that? All right, excellent. If a pipe 2 feet long vibrates 256 times per second, how many times per second will a 6-foot pipe vibrate? Okay, if a pipe 2 feet long vibrates 256 times per second, so the length is 2 feet, the vibration 256 times per second, okay? So that's going to allow us to determine what K is. We're going to multiply both sides by 2. So K equals 512. Now, we're going to take that and put it in here. So now our formula is F equals 512 divided by L. So again, we read the initial problem to determine the type of variation. We identified the variables. We established the formula. We used some initial information to determine what K is for this particular situation. Then we put that value of K into the formula, and now we have a follow-up question. How far will it fall? Oops, wrong problem. How many times per second? That was the previous problem. How many times per second will a 6-foot pipe vibrate? So the frequency will be 512 divided by the 6 feet. Okay, now, when I punch this into my calculator, 512 divided by 6, I get 85.3 repeating. Recall from your arithmetic days that 1/3 is 0.3 repeating, 2/3 would be 0.6 repeating. So this would be 85 1/3. So how many times per second? It would be 85 1/3 times. I'll put per second.
But you can write that either way and it's still considered correct, right?
You could write 85.3 repeating. The reason I went to that is in WebAssign, it's tricky to put in repeating decimals. Also, if this was actually a WebAssign answer, we would put in the improper fraction, because you may recall that WebAssign doesn't do well with mixed numbers. But yeah, okay. So that's inverse variation. Final form of variation we're going to look at is called joint variation. The general form of that is y equals kx z. Have you ever had a joint checking account?
There's a lot of jokes I want to make there, but no.
Yeah, I know. Okay, I'm talking about one where, there's more than one person on the account. Okay, so a joint checking account is something where, like, if you're married, you and your spouse share an account, that's a joint account. So joint variation, there's more than one variable on the right side of the equation. Okay, so we have y equals k xz, or it could be y equals k wr or wr squared or something like that. But there's more than one variable on the right side of the equation. Okay, let's take a look at an example of joint variation. It says the number of gallons of oil that can be stored in a cylindrical tank varies jointly as the height of the tank and the square of the radius of its base. All right, and I'm going to attempt to draw a picture of this tank. And what we have is the height is 20 feet. And the diameter is 15 feet. Okay, so that's our picture. Now, the number of gallons of oil that can be stored in a cylindrical tank. So we're going to let G equal number of gallons. Long before that was a hashtag, it meant number. So stored in a cylindrical tank varies jointly as the height of the tank. So H is going to be the height, which in this case is 20 feet. And the square of the radius, R, is going to be the radius. Now, the 15 feet in the drawing is not the radius, it's the diameter, right? The radius is half the diameter, so that would be 7.5 feet. We okay with where I got that? Mm-hmm. All right. Oh, it says the constant of proportionality, so the variation constant is 23.5. So in this particular case, they not only mention it, but they tell us the value of K. Find the number of gallons that can be stored in the cylindrical tank shown. Okay, so what's our formula going to be? The number of gallons of oil that can be stored in a cylindrical tank varies jointly, so G equals K as the height of the tank, H, and the square of the radius. So G equals K H R squared. Any questions about how I got that formula? Alrighty.
Negative.
So let's plug everything in. G equals 23.5 times 20 times 7.5 squared. So putting that into the calculator, I get 23.5 times 20 times 7.5 squared, 26437.5, and that's gallons. So this particular tank would hold 26,437.5 gallons of oil. All righty. So review, direct variation. One goes up, the other goes up. One goes down, the other goes down. Inverse. One goes up, the other goes down. One goes down, the other goes up. And joint. You have more than one variable on the right side of the equation. Okay. Now, what I want to do is I want to go through and read a sentence and then translate that into a formula with the variables. Okay. So this first one says, express each verbal model in symbols. A varies directly as the square of P. So A equals KP squared. Again, notice K is included, even though it's not mentioned. All right. How about this one? Z varies inversely as the cube of T. So Z equals K over T cubed. Okay. C varies jointly as X, Y, and Z. So C equals K, X, Y, Z. So notice here in joint variation, we actually have 3 variables on the right side. Okay, now this one says P varies directly as the square of A and inversely as the cube of J. So P equals K A squared over J cubed. So this is a mixed combo, so to speak. We've got 2 kinds of variation going on in the same problem, both direct and inverse variation. Okay. Let's see here. Now we're going to go the other direction. We're going to have a formula and then we'll write it in words. So R equals KT would be R varies directly as T. B equals K over H. B varies inversely as H. And let's see here. R equals KL over D squared. R varies directly as L and inversely as D squared. All righty. Well, that's pretty much it for variation. So you want to get familiar with and put to memory these three forms so that whatever type comes at you, you can extract that formula and then apply it. Do you have any other questions?
Negative.
Okay, well, I'm going to go ahead and stop the recording.